Welcome to this explainer. Let's simplify the fascinating mathematical world of image restoration for new engineering students.
Imagine a completely ruined, blurry photo. Can we actually reverse that mistake with math? As engineers, we sure try.
First, meet the villain, image degradation. It's basically noise or blur that totally wrecks your image quality.
And it doesn't just look awful. It literally destroys crucial data we need for things like medical analysis. But we can reverse engineer the damage. We basically model the degradation to rebuild the actual truth.
But hey, real quick, as engineering students, we gotta separate true restoration from simple image enhancement.
Enhancement is just an Instagram filter. Restoration is hardcore science, calculating and recovering the exact original pixels.
So how do we do it? First up is the spatial domain, fixing things pixel by pixel.
We use statistical models here, like Wiener filtering, to mathematically smooth out all that nasty noise.
Next is the frequency domain. Instead of pixels, we're analyzing the whole image as waves.
By turning pixels into frequencies, we use complex math to completely undo severe blur. It's kind of magic.
So why learn all these formulas? Because the real-world stakes for these models are incredibly massive.
We use these exact techniques to catch criminals, diagnose diseases, and save old historical archives. Engineering never stops. The future of restoration is evolving way beyond just traditional math. AI and neural networks are tackling crazy complex degradations that our older formulas just couldn't crack. You now know the science behind the ultimate undo button. What hidden details will you uncover next?